Good morning all. Today we are going to start our first session in the fourth quarter. This quarter we are going to start the statics course. Now, first of all, we want to know what is statics. Statics is the branch of mechanics that deals with bodies at rest and forces in equilibrium. So statics is a branch which deals with forces applied on bodies at a state of rest. First of all, we have to know what forces are. What is a force? A force is the effect of a natural body upon another one by pushing, attraction, pressure, or repulsion. So when I'm applying a force on something, when I'm pushing something, attracting something, pressuring on something, this is a kind of force that I am applying. The force is always a vector quantity because it has magnitude and direction. Magnitude is the value of the force and the direction is the way, for example, if I'm pushing a box, so the box moves in a certain direction, this is the direction of my force. And what is a natural body? A natural body is any body that has mass and volume. Now, for the unit that I'm going to use for finding the force, a force is measured in Newton, where 1 kilogram weight is equal to 9.8 Newton, which is approximately 1 Newton. And 1 Newton is equal to 10 power 5 Dalton. Now, let's say that I have a football player that is going to kick a ball. Now, when I kick a ball, this is called the force applied on the ball, and it has magnitude. I am kicking the ball with a certain force. This is the magnitude of this kick. And this kick is measured in Newton, of course, or kilogram weight, and it has a direction. Okay, so the direction of the kick is called the direction of the force. So now when I kick the ball, I have two things: the force applied on the ball and the direction of my kick. Okay. Then when I kick the ball at a certain point. We call this point at the point of action on the surface of the ball. So when I have a force, I have to deal with three things: the force, the direction of the force, and the point of action. Now let's say I have a little girl who is riding a bike, and her mom and her little brother are pushing her. Now, the mom is pushing her kid with a force, with a certain force. And of course, the kid is pushing his sister with another force, but they are not equal, okay? Of course, the mom has a greater push. So the forces are not equal, but they are in the same direction. So where would the bicycle move? It will move in this direction, right? But what is the total force that this bike was pushed by? We call it the resultant force. I have pushed the little kid with two forces. The resultant force is the total force, which is F1 plus F2. Let's say that F1 is 5 newtons and F2 is 2 newtons. So the resultant force is F1 plus F2, which is 5 plus 2, which is 7 newtons. So I have pushed the bike with a force that is equal to 7 newtons. Now R equals 7 newton, or the resultant force equals 7 newton. This is the magnitude of the force. But what is its direction? We said that the force has magnitude and direction. What is the direction of this force? Of course, it is the same direction of the push of or F1 and F2, because both are in the same direction. And what is the angle between the two forces? The angle between the two forces is 0, because both forces are in the same direction. Now, the resultant force here, we say that it has its maximum value when the forces are in the same direction and the angle between them is 0. So this is the first thing that we took, is when I have two forces in the same direction, the resultant force is equal to the sum of these two forces, and it is always the maximum value because they are in the same direction and the angle between them is 0. So what if I have a box and I have two men pushing the box from different directions? Where would the box go? In which direction will it go? Of course, it will go in the direction of the biggest force. So the resultant here force will go in the direction of the biggest one. And the magnitude of it, or the value of the resultant force, will be the difference between the two forces. So if F1 is 5 and F2 is 2 Newton, then the resultant force is the difference between them, which is 5 minus 2, which is 3 Newton. So the magnitude is 3, and the direction is in the direction of the bigger one, or the bigger force, which is F1. And what is the angle between the two forces? The angle here is 180 degrees. So here we say that the resultant force has its minimum value because the forces are in opposite directions and the angle between them is 180 degrees. So this is the second case of the resultant force. If I have two forces opposite to one another in direction, I'm going to find the resultant force by subtracting them from one another. So they give me the minimum resultant force. And of course, the angle between them is 180 degrees. Now let's say that I have the same box and the same two people are pushing the boxes from both sides in in opposite directions, but this time the two forces are equal. They are equal in magnitude, but they are opposite in direction. What will be the resultant force? Will the box move? Of course it won't move. Why? Because if I'm going to subtract the two forces from one another, the resultant force is equal to 0. So let's say that F1 is 5 and F2 is also 5. So the resultant is F1 minus F2. We are going to subtract because they are in opposite directions. So the magnitude of the resultant force is 0. And the resultant force is 0. What does this mean? It means that the body does not move. And does not move, we call it is in a state of equilibrium. Now we have studied three forms up till now, which are, if I have forces acting on the same point and in the same direction, this means that the angle between them is 0. So I'm going to add the two forces to give me the resultant force, and we say that this is the maximum resultant force. The second case we took was if the forces are acting on the same point but in opposite directions, and the angle between them is 180. So to find the resultant, we are going to subtract the forces from one another. And we say that this gives me the minimum value of the resultant force. And the third case was if I have equal forces acting on the same point but in opposite directions, we said that the resultant force will be 0 because I'm going to subtract both forces from one another. And we say that this is, we call it the equilibrium state. Now, what if I have a box and I'm going to apply two forces on it, but the two forces are not equal, they are not in opposite directions, and they are not in the same direction. Now, I have two forces like this. Now, what will be the resultant force? The resultant force will be F1 plus F2. What do you think? Of course not. The resultant force will be something like this. it will be an inclined force, making an angle with the first force, and we can represent it by this drawing. We represent F1 and F2 like this, and we say that between F1 and F2 we have an angle which is called alpha. And to find the resultant force between these two forces, the resultant force will be somewhere in between with an angle, we call it theta. This angle lies between the resultant force and the force F1. The rules that we are going to use to find the value of the resultant force and the angle theta, because the resultant force is its magnitude is its value, and its direction is the angle theta, which is inclined between F1 and itself. So the rules that we are going to use is the resultant force is equal to root F1 squared plus F2 squared plus 2F1 F2 cosine alpha, and the direction is tan theta, which is F2 sine alpha over F1 plus F2 cosine alpha. Now let's take some examples. Now example 1, it says two forces of magnitude 5 Newton and 3 Newton act on a point and include an angle of measure 60 degrees. Find the resultant in magnitude and direction analytically. Now, as we said, first of all, I'm going to find what is given. Now, the given is F1, which is 5 Newton, F2, 3 Newton, and alpha is 60 degrees. Now, what am I supposed to find? I'm supposed to find resultant and its direction, which is angle theta. What are the rules that I'm going to use? The two rules that I'm going to use are R equals F1 squared plus F2 squared plus 2F1 F2 cosine alpha. And to find the theta, I'm going to use tan theta, which is F2 sine alpha over F1 plus F2 cosine alpha. Now let's substitute. R equals 5 squared plus 3 squared plus 2 times F times 5 times 3 times cosine 60. This will give me 7 Newton. Then I want to find the value of the angle. So tan theta equals F2, which is 3 times sine 60 over 5 plus 3 cosine 60. Then I'm going to find shift tan, the answer, and it will give me theta equals 21 degrees and 47 minutes. Now this is the magnitude and the direction of the resultant force. I have two forces that are inclined to get on each other by an angle of 60 degrees. Now I found the resultant force and its direction, which is the angle theta. Another example, if I have two perpendicular forces of magnitude 6 Newton and 2.5 Newtons acting on a point, find the resultant in magnitude and direction analytically. Again, the given is, I'm given F1, 6 Newton, F2, 2.5 Newton, and I am given alpha equals 90 degrees. Because they are perpendicular on one another. So I know that alpha is equal to 90 degrees, so cosine alpha is 0 and sine 90 is equal to 1. And the rule I'm going to use is R equals F1 squared plus F2 squared plus 2F1 F2 cosine theta, and theta equals tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. What I'm supposed to find is the R and the theta. Now let's substitute. My rule is R equals F1 squared plus F2 squared plus 2F1 F2 cosine 90. And since cosine 90 is equal to 0, so this term is equal to 0. So R equals F1 squared plus F2 squared. So R is equal to 6.5 Newton. Then I'm going to find tan theta. If I look at tan theta, here I have cosine alpha. Sine alpha is equal to 1, which is sine 90, and cosine alpha is equal to 0. So the tan rule will be f2 over f1 plus 0. So it's f2 over f1, which is 5 over 15. And from it, I can find that theta equals 22 degrees and 37 minutes. So this is the magnitude and direction of my resultant force. So the rule now, this is another rule that we have just said, with if alpha equals 90, the resultant will be f1 squared plus f2 squared under the root, and tan theta will be f2 over f1. So this session, we have taken two rules. The first one was this, the resultant rule is f1 squared plus f2 squared plus 2f1 f2 cosine alpha under the root, and tan theta is f2 sine alpha over f1 plus f2 cosine alpha. The second rule we took is if alpha is equal to 90 degrees, then the resultant will be f1 squared plus f2 squared under the root, and tan theta will be f2 over f1. Thank you. Now you are going to go answer your evaluation question and then your homework. Thank you again.